uh, how to reverse the transformation. So how to reverse? Anybody can do anything, but they cannot do. They can read cipher text. They can read, but they cannot understand unless it is reversed back from cipher text to plain text. They will not understand anything. The sender applies encryption function. We call it as encryption algorithm on the plain text. The resulting text, you call it as cipher text. So cipher text is the one which will be transmitted over the network. And of course, receiver applies decryption function or decryption algorithm, function or algorithm that inverts the encryption. And of course, you can recover the original plain text. When the original plain text is available, certainly you can easily read it. And of course, cipher text is transmitted across the network, is unintelligible. That means nobody can read. Of course, nobody can understand. That is what we call it as unintelligible. To any eavesdrop also can do, assuming that eavesdropper doesn't know the decryption function. What is the decryption function? He doesn't know. On what basis the encryption has happened, he doesn't know. So since the same encryption he has to do for decryption also, that he will never understand. So definitely gone. He'll never understand. It is gone. So that's the thing. And how exactly encryption work? Encryption and decryption functions should be parameterized by key. Key here is nothing but here is we call it as the encoding algorithm, maybe conversion algorithm. I think every character in your text character is having ASCII value. So suppose the ASCII value of A is 65. So for this 65, you add plus 31. So 31 is your key. 65 plus 31, you get 96. So for 96, there is a character, you call it as exclamatory character. So capital A is represented as 96. So that is exclamatory mark like this. It is represented as an exclamatory mark. So wherever you have A is represented as exclamatory, exclamatory, exclamatory. Similarly, B, capital B is added with again 31 and you get 97. So 97 means, 97 is small a. So B is nothing but it's a small a. It's a small a. So people will never understand. Oh, exclamatory a. Okay, exclamatory a. They will not understand. It will be a crypted text. Look at here. One simple example he is just giving. He's sending a message. Bob is sending a message, and he using some encryption key, some algorithm. What he does. The entire character H is converted into some character, E is converted into some character, L is converted, L again, O is converted into some character. So you observe here, this is overall, it's an encrypted text, cipher text. This cipher text, if you read also, you will not understand what is that you are certainly writing. The same text is transmitted over a communication link. It is transmitted over communication link. Once it is received at the receiver side, what happens again? You use a decoding algorithm. So this decoding algorithm will convert back this message to normal text. So it will convert back to normal text. Once you convert back to normal text, certainly you will get the message. The encryption and decryption are functions that parameterized by key. Key is nothing but here I said 31 is my key. Somebody who wants to decrypt it, Okay, at the receiving side, they have to minus 31. They have to do this. 31 is the secret key. If you don't have this 31 secret key, certainly they cannot decrypt. You'll never get back. And furthermore, the function should be considered public knowledge. The same key needs to be secret, and only Alice knows what is the key that Bob has used, and Bob also knows what is that key Alice is going to use. So Bob and Alice, they use cipher key, and the cipher key is available. So here, the cipher text produced by a given pair of plain text depends upon the both encryption function and the key. Yes, what is the key value that you are certainly doing? So for A, I'm adding. So my encryption function is addition by 31. I can certainly do some other operations also. So instead of adding, I can certainly multiply 65 multiplied by 31. I do something, some other value, I get the same value, I transmit. And what I get here, what operation I'm doing, that is your algorithm. Algorithm is nothing but what operation. And what is the value that you are using for doing that operation? That is what your key is about. So you have encryption function. Encryption function does the operation, and key is the value on which this encryption function is going to, convert your plain text into ciphertext, and the ciphertext is transmitted. So this is the very important thing that you should understand. Remember, to encrypt or decrypt, you require both the algorithm plus the key value. You need function, that is algorithm, and also the key value in order to convert this. Even somebody eaves also, they will not understand. So that is a technique that is being followed in encryption. Right. Further, we have next concept called symmetric key cipher. What is symmetric key cipher? It's a technique. It's a technique. So sender is sending a plain text. You do an encryption. Encryption using the key you will do. Same key is shared with the receiver also, and receiver uses the same key, same type of key to decrypt it, and you will get the plain text. So this is for encryption also same key, for decryption also same key to get the plain text. So in between the network, it will transmit as a ciphertext. That is, in symmetric key cipher, both the participants in the communications share the same key. Very, very important. They share the same key. Very, very important thing. They share the same key. That is a very, very important thing that you should have. And this key is always shared before actually you do encryption and decryption. They should know. And that's why whenever you install a new software, they provide a key. So when you use that key, what happens? The software get unlocked and it is installed. Somebody tried to write something. Okay, right? So that's what we see in the symmetric. They use both same key, shared same key. They will certainly use. In other words, if the message is encrypted using a particular key, the same key is used for decryption. That's why it is called symmetric. It is called symmetric because the key which you use for encryption, the same key it is being used for decryption also. The same thing. So that's why it is called symmetric cipher. And of course, if the cipher is illustrated in the figure, okay, with the symmetric key. That's why you see the shared key. It is also called shared key. Symmetric key ciphers are also known as secret key ciphers. Secret key ciphers, shared key ciphers, they are also same. So these key, if you share, that's all. Anybody can hack. Don't share the key. And that's why your OTPs come, right? So whenever you are doing transactions, OTP will generate. OTP will come to you. So don't share OTP with anybody. So OTP is nothing but it is the shared key. If you put that OTP for your transaction, what happens? The entire transaction is converted into normal text and your server will understand, and it will understand that the entire transaction is correct. That is what you call it as shared key. The OTP, it is one-time password, OTP, you will get. The same OTP is nothing but it is a shared key. If you share it with somebody, gone. So it will be hacked. Anybody can decrypt it, and your entire process is, being hacked. So that is one thing that you should understand. Next, during this encryption, you will find one very technical term. We call it as electronic code book. Electronic code book. So you have the plain text. Using the same key, what happens? Encryption happens. Next, remember, the entire text will not be encrypted. So entire text is split into blocks. You see, this is a block of some 20 characters or 30 characters. 20 characters or 30 characters, 20 characters. Some block of 30 characters, 30 characters, 30 characters, 30 characters. For that, they will apply this secret key and they do the encryption, and they'll get the cipher. They'll do for the same key, and but the administrator, what is the guarantee that administrator also can hack? So this is a biggest problem. We call it as electronic code block. Administrator is the one who provides the key, right? If the administrator comes to know about this key, what is the guarantee that he will never hack? Maybe he can hack. So that is the biggest problem. So electronic code book, this is nothing but the entire process of converting this plain text into a cipher text using a block of code. So this is one block, this is another block, this entire block, we call it as electronic code block conversion. So this is first point. Let us see. Most ciphers are block ciphers. Block ciphers in the sense they are defined to take input of plain text blocks, one block, usually of the size is 64 bits or 128 bits. They will take the set of bits, they convert into a cipher block. So this cipher text conversion, the entire block which you can convert, so we call it as electronic code block. Using block cipher to encrypt each block independently, known as electronic cipher block. This is a mode in cipher. Okay, this is the same type can be applied for any text, any set of text. But ECP has a weakness. What is that weakness? That given text block value will always result in the same cipher block. Always result in the same cipher block. Here, look at here. A means it is some character. Same. A is nothing but same character. A is nothing but same character. A is nothing but same. Everywhere A will be same. Same character. Oh, you will easily understand. Oh, if the regular pattern is repeating, in place of A, everywhere you are getting exclamatory, exclamatory, exclamatory. Oh, you will easily understand. So exclamatory is nothing but A. The hacker will, think, and he will decode it very easily. So this is a problem with ECB. ECB, electronic code block, uses the same encryption for all the data. Same encryption. So recurring blocks, the same type of blocks, recurring blocks values in the plain text are recognizable as such in the plain cipher text, making it much easier for crypto analytics to break the cipher. Easily they can break. If they see the same pattern of text, easily they can cipher. They can break the cipher. So there are experts. By looking into that, they will say this character is nothing but this. They have, they have encrypted like this. Easily they will understand. They'll break it. And another solution for this, how to come out of, or how to overcome this electronic code blocking. So we have a technique called cipher block chaining. We have cipher block chaining. We call it as CBC, cipher block chaining. So cipher block chaining, what is exactly it? Let us see what is exactly it. First point. So that was the problem. Anybody, if the pattern of the characters are repeating, if A is always, if A is always represented as exclamatory mark, easily they'll understand. If B is always represented as a question mark, they will easily understand. B means question mark, easily they will understand. If the same character is coming, if the same character is coming, they'll easily track. So what to do? How to prevent this? So to prevent this, block ciphers are always augmented to make cipher text for a block varying dependent. So that means one block of data, if it is containing A, B, and C. So ABC is written as exclamatory, question mark, and at some symbol. So A is nothing but question mark, B is nothing but A is nothing but exclamatory, B is nothing but question mark, C is nothing but at some symbol. Anywhere if you put, easily people will understand because the same patterns are repeating. So what they'll do, in one place A is represented as exclamatory, in another place A is represented as equals, in some other place A is represented as tilde symbol, A is represented as slash symbol. So it is varying. So block is varying. The text in the block, if you vary in different places, different this one vary. Sir, if you vary, okay, you will understand. But how to decrypt it? Yes, for that also there is a technique. That is what been told in cipher block chaining. Okay. So this block varying depends upon the context. The way in which block ciphers may be augmented. Augmented means added extra. This is called mode of operation. Some extra components you will going to add along with the cipher. You call it as mode of operation. So in mode of operation, what you do? So the common mode of operation for cipher block chaining is CBC. CBC is nothing but cipher block chaining, in which each plain text block is XORed with the previous block's cipher text before being encrypted. For example, you see, if I take one simple example, so let me take ABC. Imagine ABC I have, and this is a block. This block is converted as exclamatory, question mark, and at some symbol. So if it is converted like this, at some symbol like this, what happens next? You get B, A, X. So what happens? BAX, if you want to convert, B means question mark. If you write, oh, people will easily understand. A means, exclamatory, they will easily understand. So what they do, whatever the value get out of this value, they will augment, that is, they will going to do XOR operation to the previous block's ciphertext. So this is the original block. The original block is converted into previous block's ciphertext. So that is ciphertext you are converted here, and this converted ciphertext is XORed. So you are going to do XOR operation. XOR operation you do with the previous block data. With the next block data, you will do XOR operation and you will get something else. So now when you do XOR operation, you will get differently. B is supposed to be question mark. Here B is not question mark. It is B becomes equals, because B is XORed with exclamatory mark, and question mark will become a star, and your X becomes A. So you see, and this is your ciphertext. This ciphertext again, it is XORed. It is XORed with the next block of plain text, and you will get ciphertext. So this is what you call it as chain. See, chain. It's a cipher block chaining. The previous block cipher is XORed with the next block's text, and it will get some cipher. That cipher is XORed with the next text block, and it is ciphered. And again, that ciphering text, it is so like this. This process will continue for all the blocks. This will continue for all the blocks. Look at this diagram. You're having a text. You're having a text of 0 block, 1 block, 2 block, 3 block. The first block, 0 block, of course, it doesn't have anything. So it will have an initial value. We call it as initial vector. This initial vector and block cipher, it is added, and you'll get a ciphertext. This ciphertext, whatever you are getting, again, it is been added with the block 1. It is XORed with block 1. So it is a block 1. So, and it will get ciphertext 1. So this is C0. C0, ciphertext 0 is XORed with the block 1, and you get C1, ciphertext 1. And this C1 is again XORed with block 2, B2, and you will get C2. And this C2 is again XORed with B3. It is, you get C3. Now C0, C1, C2, C3, they'll combine all these things and they'll write it as one small ciphertext, and these block texts, cipher block texts, are sent to the network for transmission. Even some expert, if they see also, they cannot understand. They cannot understand. So this is the technique to follow. This is a technique to follow, to avoid electronic load block problem. So what happens? The result of the first block ciphertext depends upon the part of the preceding blocks. And of course, since the first is a plain text block, has no preceding blocks, it is XORed with a random number, which you call it as initial vector, IV, initial vector. So which includes a series of ciphertext blocks. So that will be proceeded for decryption. This is all. This chain. So if you want to get the ciphertext of block 1, you need ciphertext of block 0. If you want ciphertext of block 0, you need initial vector. Initial vector XORed with plain text block 0, so you'll get cipher 0. This cipher 0 with the block 1, cipher 1 you get. This cipher 1 with block 2, you get cipher 2. Cipher 2 with block 3, you get cipher 3. So these cipher 3, cipher 2, cipher 1, cipher 0, all these things are sent. All these are sent. So this is how your blockchaining work. Very, very important question in the examination. What is blockchaining? What is electronic block book? How exactly they are related? Why they are used? All those information has to be, discussed. And of course, this is one such technique that is being followed in symmetric encryption. Right. In the next class, we'll discuss about public key encryption, public key ciphers. We'll discuss in the next class. That's all for today's class. We discussed what is encryption, how exactly encryption works, what is electronic code book, and finally we discussed about uh, code blockchaining, how exactly code blockchaining. That's all for the day. The entire class video and study material are available in the website. That's all for today's class. Thank you.